All right, demo D1. So this is an example of an exam I've given in the past, and we're just going to walk through how to solve it. So at the beginning, we'll sign the academic conduct code. So this is just my name, and then yes to all these things, all these nice things. Okay, so the first question, we have Ginny's holiday decorations, which, every year the Hogwarts Decoration Committee solicits donations of 2 galleons from the student body. The more funds we raise, the better the decorations. And we're told that there's a common area that we're decorating, and you don't have to donate to enjoy the decorations because it's just in a common area. So you can enjoy the donations no matter whether you donated. So this is a public good. It's non-rival, it's just in the common space. You don't use it, but you can experience it. And then it's non-excludable, so it's in the common space. So this is a common resource. So then we have a matrix below, which might look a little bit funny, but it's representing the payoffs associated with the decorations for 2 players. We have Ginny as 1 player, and then everyone else as another player. So this is sort of a different type of setup than what we've seen before. But one of the amazing things about game theory is we can really look at very different types of contexts using the same type of approach that we've used before. So let's walk through this thing and solve this game. So before we approach any of the other problems, what I want to do is just find Ginny's best response. So so what if everyone else is contributing? What should Ginny do in that case? Well, Ginny is given a choice between contributing and not contributing. And for her, if she contributes and everyone else contributes, then she gets a payoff of 18.2. And if she doesn't contribute, then she gets a payoff of 20. So 20 is greater than 18.2, so we'll put a box around 20. And then if everyone's not contributing, then if Ginny contributes, she gets a payoff of negative 1.8. She's like the only one who's contributing to the decorations. No one else is. And then if she doesn't contribute, then she gets a payoff of 0. 0, is the sort of baseline, no contributions, but she's not contributing anything. So this is the better one. 0 is greater than negative 1.8. Okay, so then we could go through and play on the behalf of everyone else, but it's a little bit funny to do that. So all we're asked for is Ginny's contributions or not. So her best response. And in this case, we're asked if Ginny has a dominant strategy and then which one it is. So it turns out no matter what everyone else is doing, we as Ginny should not contribute. So we're going to circle D. We're not contributing in every possible way the rest of Hogwarts decides to go. Okay, so then the second part of the question is to find the socially efficient strategies. We're going to look for the pair of strategies that maximizes the welfare of society. So in this case, we're going to, we can definitely rule out these first 2. Those are very small numbers. The numbers here are a little bit closer, but we can see that 20 plus 1800 is equal to 1820. But so this one is greater than this one by 18.2. So this one is going to be the socially efficient pair. So I'm just going to put a box around this one, or I guess we could circle it if we wished. Okay, and maybe we'll put a box around this. Just keep it nice. All right, so then what's the phenomenon here? Well, we've talked about 2 types of phenomenon. One, we have the tragedy of the commons, which is what we observed in common resources when there's an over-extraction. It's a good that's rival and non-excludable. And so in that environment, we get too much being used. Here, this is a public good. It's a good that's not rival. And just like common resources, public goods are non-rival and just like common resources, non-excludable. So here, this is a common resource, a public good. And what we get is this type of problem where players choose to not contribute. And this is what we call the free rider problem. So it's the very similar problem to the tragedy of the commons, but in the context of public goods. So this is the free rider problem. Okay, nice. So if we were looking at common resources, we would say that this is the tragedy of the commons instead. All right, so question 2, we have the Hogwarts holiday decorations. So, knowing the problems that were faced in the first part, the committee instead proposes raising everyone's tuition by 2 galleons, which would fully fund the decorations. And then we have 25 on-campus students with different willingnesses to pay based on their house. So we have data on their willingness to pay or their marginal benefits represented in this table. So we have 25 students per house, so each student's willingness to pay is represented in the table above. So our one example here is we have 16. 16 is the willingness to pay for Hufflepuff, and we have 25 students. So this would be the total willingness to pay for Hufflepuff. Okay, so we're going to try to evaluate a couple of things. So if the proposal to raise everyone's tuition by 2 galleons to cover the cost of the decorations were voted on by the student body, what percentage of the student body would vote yes? So we need to check this 2 galleons against the willingness to pay of each one of these houses. And so Hufflepuff, for each individual, we don't even have to count up the number of students yet. Hufflepuff, comparing 16 to 2 galleons, everyone would vote yes. Gryffindor, everyone would vote yes. Ravenclaw, everyone would vote yes. And Slytherin, everyone would vote yes. So this is 100%. So the marginal social benefit, marginal, associated with fully funding the decorations. So here, we want to find the marginal social benefit in total. So to do this, we need 16 times 25. So this is the marginal benefit for Hufflepuff. Then we add this to 20 times 25 for all of the students in Gryffindor times their willingness to pay, plus 24 times 25 plus 20 times 25. Okay. And so we can just plug this into a calculator, but this is also equal to, so it's 4 different houses times 20 times 25. Okay, so that's 100 times 100 times 20. So it's 100 times 20, which is equal to 2,000. Okay, so we'll just enter this here. This is 2,000. And then the next 2 parts of this question are about the costs and the efficiency of this thing. So we'll just go through and do that. So the last two questions, what's the marginal social cost associated with funding the decorations? Well, we would have to take 2 galleons from everyone, and then we have 25 students in 4 houses. So in total, there's 100 students. So this is 200. Okay, and then is this socially efficient? Yes. And we know it's socially efficient because the marginal social benefit is greater than the marginal social cost. We know the marginal social benefit is 2,000 and the marginal social cost is 200. So this is like very clearly socially efficient. But the problem, as we saw here, and I mean, this is just an exam, so we don't actually have to talk this through when we're solving these things. But the problem, as we've talked about in class, is often we have these socially efficient, public goods type examples where individuals following their own individual incentive free ride, and then we don't get the nice things. So sometimes we can put things up for a vote and fix them. Okay, we'll leave this here. I will see you in the next one.